Hey guys, in this video, we are going to be going over the graphs of tangent and cotangent functions. So as you can see from the pictures of their parent functions, they are really similar. There's two main differences. The tangent function does go through the origin, whereas the cotangent does not. Other thing is that tangent has kind of a positive direction, so it starts at the bottom and curves upwards. Cotangent has a negative direction, so it starts at the top and curves downward. So before we move on, let's take a closer look. So this is our tangent function. Notice that this one has these blue dotted lines. These are vertical asymptotes. These are all the values for which tangent is undefined. Okay, so if we're going to go through and label what each letter does to the function, you have to take notice of a few things. So when looking at this tangent curve, there's 3 reference points that you want to look at. These points that I'm writing here. So our A value lets us know how much distance there is between one of those reference points to the midline. Okay, the period of this function is pi. So this one is a little shorter than our sine and cosine. C stands for phase shift. So since this is a parent function, there is no phase shift. So what you're looking at is that it's going through the origin, or you can say that C is right there in the middle. And then plus D, D affects the midline of the graph. So midline, or in other words, that is D. Okay, then let's take a look at cotangent. So really similar. Again, we have those reference points on the curve. And A tells us how far away that reference point is going to be from the midline. The period is pi units long. C is right in the middle. And D is the midline. Okay, we are going to be graphing these in a few minutes. So when you're graphing these, there's a few things to keep in mind. So let's look at tangent. What I want to do is just graph one complete cycle of tangent. So the way tangent works is that there is a vertical asymptote right down the middle of a single period. On the left side, you will see half of a curve. So it has that midline point and one of the reference points. On the right side of this is the other half. So again, it has the midline and a reference point. So this right here makes up one period of tangent. Okay, cotangent is a little different. So cotangent begins and ends with a vertical asymptote. Then it follows one smooth curve going downwards. So reference point, midpoint, another reference point. And this is one entire period of cotangent. Okay, then I have the transformations labeled there. So vertical stretch is absolute value of A. Period is pi over B. So just be careful. This is different from the other ones that we've done before. Phase shift. When you have subtract C, you are moving to the right, and plus means you are to go to the left. For vertical shift or midline, when you have minus, that means you are moving down, and add would be to move up. So now using all this information that we have here at the top of the screen, we are going to graph two functions. We're going to graph one of each, one tangent and one cotangent. So let's take a look at the first one. So we have f of x equals 3 over 2 tangent of 1/2 x minus 1. So let's start by identifying what each of these numbers represents. So 3 over 2 is our a value. It's the first thing you see after the equal sign. 1 over 2 is our b value, so it's in parentheses, but it's in front of the x. And then last, that minus 1 is our d value. It's at the very end, and it is not in parentheses. So using these numbers, let's identify all of the characteristics. So vertical stretch is going to be 3 over 2. Comes straight from the a value. Period is pi divided by b, and b was 1/2. When you perform that division, it gives us 2 pi. So phase shift, we did not have a c value, so we have none. Vertical shift, there is a minus 1 at the end, so it is going to go 1 down, which means that our midline is at y equals -1. So using all this information, I'm going to draw some guidelines for myself on top of this graph. So starting with midline, we said that midline was going to be at -1. So I'm going to draw a horizontal line right there at -1 just to remind myself of the midline. Let's label it with an M. Okay, phase shift, since we don't have one, I'm going to go ahead and check it off. But that just means that we're going to begin one of our phases right at the 0. So right on top of that y-axis. Okay, period is 2 pi wide. So starting from the 0, you want to finish your period 2 pi units away. So that's right here. It's even labeled 2 pi. So I'm going to write this as the bottom as well. P equals 2 pi. Okay, and then last, the vertical stretch is 3 over 2. So that means that from the midline, our reference points are going to be 3/2 units up and 3/2 units down. Whoops, let me try to draw that a little straighter. So 3/2 is the same as 1.5. So I just try to do 1.5 units away. Okay. So remember that this time around we are doing the tangent function. So let's take a look at tangent. So one complete cycle or one complete period of tangent looks like this. So the easy thing for me to spot right away is that it's going to have a vertical asymptote right down the middle. So exactly in the center. So here I have it blocked off how long the period is going to take. So exactly in the center of that, there needs to be a vertical asymptote. And I'm just going to kind of eyeball this. If period is 2 pi, another period would fit here. Down the middle would be right at -pi. So I know that there's another vertical asymptote here. Okay, what else can we get from that reference? So I have half of my curve going up on the left side of the asymptote, and then half of my curve pointing downwards on the right side. Okay, so starting at the beginning of the period, we're going to start at the midpoint. And then because it's curving upwards, I know I'm going to have another reference point here. And just get close to the dotted line without touching. And then on the other side of the period, so at the very end, midpoint. And then the lower reference point, just kind of curve it down. Okay, so that is one complete cycle or one complete period of tangent, but we're going to keep repeating this pattern until we run out of space. So something like that. This would curve upwards, this would curve downwards. Okay, and that is the graph of our tangent function. Okay, let's take a look at another example. This time we're looking at cotangent. So I have f of x equals 2 cotangent of 3 pi over 4 plus 3. So again, I want to label these values. So right away, I know that that 2 is the a value because it's right after the equal sign. That 3 pi over 4, this is our c. It is inside of the parentheses, but after the x, which means that that last number is d. Using these numbers, let's find all of our attributes. Okay, so vertical stretch is going to be 2. Period is always pi divided by b, but since we didn't have a b, we're going to put a 1 as a placeholder. And pi divided by 1 is still pi. Phase shift. So this time I have 3 pi over 4 inside of the parentheses, but since it is minus, it is going to be moving to the right. Vertical shift, 3, and it's plus sign, so it's going to be moving up, which means that our midline is at y equals 3. Okay, we're going to use this information to start drawing some guidelines for ourselves. So starting with, midline is going to be at positive 3. And I'm going to label that M for mid. Phase shift is we're going to go 3 pi over 4 to the right. So don't let the pi part confuse you. It is still fraction. It's still 3 over 4. So if pi takes 4 squares, 3/4 would be 3 squares. So I'm going to label that as just C since it's going with that. Period is pi units long. So we already established that pi is 4 squares. So starting from the C, we're going to go 4 squares. 1, 2, 3, 4. Which means that this makes up 1 period of our cotangent function. And last, the vertical stretch is 2. So starting from that midline, so starting from here, our reference points are going to be 2 squares higher and 2 squares below. So this distance is 2. Okay, so I think we have enough guidelines. We can start drawing this function. So this time we are doing cotangent. So looking at cotangent, it's a little simpler in my opinion because it both starts and ends with a vertical asymptote. So the period that I have marked off there, I'm going to put a vertical asymptote at the beginning and at the end. So just by looking at this, it looks like we're going to have a vertical asymptote every 4 squares. So I'm going to go ahead and draw those in. Every 4 squares. Okay. Now taking a look at the reference again. So it has reference points, the upper one, then mid, and then the lower reference point. So we're going to do that here for ours. So within that period, we're going to space things out evenly. The good thing is that we have 1, 2, 3 lines. So each line is going to get a point. So upper reference point, middle reference point, lower reference point. And just be sure that when you are connecting these, you do make a curve. It is not a straight line. Okay, and now let's just keep repeating that pattern until we run out of space. Upper, mid, lower. Upper, mid, lower. Upper, mid, lower. And it should have arrows at both sides. Let me go and fix that. And there would be a little piece here. Okay, and this is the graph of that cotangent function. Okay, so with tangent and cotangent, make sure that you're always able to identify where the midline is, and you'll be able to see it pretty obviously because the curve will start there. And also be conscious of where you put these vertical asymptotes, because those guides really help us out a lot. Okay guys, this is all for tangent and cotangent. Let me know if you have any questions.